This is the 2012 AP Calculus free response question number 2, scoring. So our first question, we have our questions restated up here. On question number 2, part A, we came up with an answer of 2.986 using these two integrals. It looks like the answer is in fact 2.986 or 2.985. They accept either one because that's rounding or truncating. That was a 3-point question. So that the points are for the integrand, the limits, and the answer. Well, we are integrand. So the integrand means what's inside the integral. Now notice they have two options here. They have this option or this option. The second option is the one that I've called method 1. This is integrating with respect to x. So they say the integral from 1 to a of ln of x dx plus the integral from a to 5 of 5 minus x dx. That's what I started with here. And then we also found out what that a was, and we integrated that, and we got 2.986. So the integrands are correct here. Notice that I could have the integrands correct and the limits wrong and still get a point. Or I could have the limits right and have the integrands wrong and still get a point. And fortunately, I've got both the limits and the integrands right, and I've got my answer right. So that's my 3 points for the integrand, limits, and the answer. If we compare that to the method 2, which was their first method, that's integrating with respect to y. So we have the integral from 0 to b of 5 minus y minus e to the y. Notice they don't even bother to write the value of b because it's assumed that we can't get the answer without finding that value of b. We were nice and wrote that down in this problem, but I didn't write it in the others. But we don't need that value of b. That's not the question. The question is, did I get the integrand, the limits, and the answer? Well, my integrand, that's what's inside the integral. The integrand matches theirs. The limits, 0 to b, those match. It doesn't matter if I call it b or c or I put the 1.307 in, as long as I show that I know the correct terminus for that limit. And my correct answer is 2.986. So we got all 3 points for that. No matter which way we did it, we got 3 points. We got that one. For part B, they say that the volume is equal to the integral from 1 to a of ln of x squared. We have the integral from 1, and we were nice enough to give them a number there, 3.693, instead of just leaving it a, of ln of x squared. And then we have plus the integral from a to 5, and again, we were nice enough to put in the number 3.693 instead of just leaving it a. And 5 minus x squared. So the important features here, if we have ln x and 5 minus x and they're both squared, ln x and 5 minus x and they're both squared, and we have our limits from 1 to a and a to 5. And so we got, in this case, 2 points for the integrands. So the way they've done the points here, by having 2 points for the integrands, that means we need to get both integrands correct in order to get the 2 points. If we had either one of these integrands wrong, 0 points, even though we got one of them right. We still need to have both integrands to get 2 points. And then the expression for the total volume, that's this total expression here. So that's the one that we already checked before. And so we know that's right. So that was a 3-point question. So the scoring here was 3, 3, and 3, which is unusual for them to have it so evenly divided. Their part C, I see that they did quite differently from the way I did part C. So what I did, if you recall, is I said there are 2 areas. We're going to say that the two areas are equal to each other. So we made an expression, an integral for one area and an integral for the other area, and said that they had to be equal. What they've done instead is said, well, we know what the total area is. The total area was 2.986. We got that from our first answer. And then they said, well, the area, the first of my two areas, integral 0 to k of 5 minus y minus e to the y dy, that, since for the two areas to be equal, that must be equal to half of the total area. So that was how they chose to solve that. If we solved this for k and if we solved this for k, we're going to get the same solution. So this equation is in fact mathematically equivalent to this one, although it's a fairly different setup. And I'm surprised they didn't have an or and show that alternative possibility. Our points are for getting the integrand, the limits, and the equation. Well, we have an equation by saying these two are equal, and it's a correct equation. Our integrand is a little bit different from theirs, but our integrands actually are the same integrand as their integrand. We're just using it in a different way. And our limits again are a little bit different. They are doing 0 to k, and they're only doing one of the two integrals. I have two integrals, 0 to k and k to 1.307. So the way that I've written this integral, I have to get both of these limits to get them correct. But we do have a correct equation that relates the two integrands and has these particular limits. So I believe we've got points for the integrand, the limits, and the equation. And that's worth 3 points. So it looks like we got all points on that one. And that is question number 2 from last year's AP exam.